Good morning, everyone. I welcome you to day one of the 2021 Soybean Summit. I'd like to thank you all for being here today. Excuse me. We are excited to say hello to each and every one of you and hope you are able to take away a lot of useful information and ideas to improve your operation. A reminder that this is the first of 3 days of our Soybean Summit events this year, with the next 2 sessions on February 17th and the 24th. Hello again, my name is David Wessel. I'm an at-large director for the Illinois Soybean Association. I reside in Sharonville, Illinois, and I also serve as chairman of the ISA Utilization Committee. I was previously an ISA Soy Ambassador and past chairman of the Cass County FSA Committee. I currently stay involved with Clear Lake Drainage District, Cass Morgan Farm Bureau, and Illinois Farm Bureau. My wife Tama and I have 2 children, 1 grandson, and we raise corn, soybeans, wheat, cereal rye, cattle, and hay on our 100% no-till farm here in West Central Illinois. I want to welcome you all to today's event, the first of 3 days where you will hear from expert speakers sharing the latest in soybean agronomy, sustainability, production, and agribusiness management. We hope these presentations will deliver the knowledge and tools needed to overcome any challenges this season may bring. To give you a rundown of what to expect during today's event, we'll begin this morning with a keynote presentation. After that concludes, we'll take about a 5-minute break before breaking up into 3 different breakout tracks. The Soybean Summit event is just one example of your checkoff dollars at work. Your soybean board is working hard to use those funds to help you be more successful and profitable. As we are getting started this morning, I would like to highlight a few of those additional opportunities. If you are interested in hearing more, please feel free to reach out to any ISA staff or director like myself. ISA has recently relaunched its Field and Bean magazine. The relaunch is a deliberate approach to making sure both Soybean Checkoff and Illinois Soybean Grower membership content bring value to our state's 43,000 soybean farmers. Bringing Illinois Field and Bean back also fits well with ISA's fiscal year 2021 efforts, putting today's soybean farmer needs at the center of all projects funded by the Checkoff program. Illinois Field and Bean magazine can be read online at www.ilsoy.org. Fueling Illinois starts from soy from Illinois. Illinois farmers like you are growing more than crops in your field. You're growing a sustainable energy. That's because your soybeans can be transformed into soy-based biodiesel. B20 is a blend of 80% petroleum diesel and 20% biodiesel, and is now a high-quality fuel option that can power your equipment year-round, in addition to offering many environmental benefits. In addition, using B20 to fuel your farm is like putting money back in your own pocket, because B20 biodiesel adds more than 10% to the price of your soybeans. For more information about ISA's biodiesel efforts, please visit ilsoy.org. Let's talk AMP. AMP, the Agribusiness Management Program, is an exciting new offering of the Illinois Soybean Checkoff program. AMP is a resource for busy farm families and agribusiness professionals. It's designed to provide farmers with the go-to advice and guidance on many agribusiness management topics, from succession planning to marketing. Browse your online AMP resources on illsoyadvisor.com. And stay tuned for announcement on webinars and events you won't want to miss. AgTech Connect is another exciting new program funded by ISA's Checkoff program that connects ag tech companies with farmers interested in testing the latest on-farm innovations. It's all about encouraging development and adoption of technologies to help Illinois soybean farmers improve on-farm yield, profitability, and sustainability. This program is just another way the Illinois Soybean Association works to be a trusted resource for soybean farmers and ag tech companies across the state. For more information on the AgTech Connect, please visit ilsoyadvisor.com. And finally, I encourage you to visit ilsoyadvisor.com, not only for more information on AMP and Ag Tech Connect, but to check out our year-round agronomic source for farmers, agronomists, CCAs, and soybean stakeholders, and to learn more about upcoming events, webinars, useful information for your soybean production needs. If you registered early, you should have received a box containing a hard copy version of today's event agenda and tips for using the online platform on the other side. These tips will ensure that you have the best summit experience possible and will also be available online through the handouts tool. There are multiple sessions during the event where any CCAs in the audience will have the opportunity to earn continuing education credits. We will have details at the end of the session on how to access your credit. We appreciate the opportunity to partner with CCAs to offer this additional benefit today. Now I'd like to take time to recognize the ILSOY Advisor Award winners. Beginning with the 2021 Soybean Master Advisor. ISA created a CCA Soybean Master Advisor Award in 2016 as part of its mission to help Illinois soybean farmers excel in the global marketplace. Each year, an Illinois Certified Crop Advisor is nominated for the Soybean Master Advisor Award as a way to recognize and reward them for their passion for soybean management. Excuse me. This year, Randy Niver of Potomac, Illinois is being recognized as a 2021 Soybean Master Advisor. Randy has been a CCA since 2012 and works as a technical agronomist for DeKalb and Asgrow in East Central Illinois. He received his bachelor's degree in Ag System Management from The Ohio State University in 2007 and his master's degree in Crop Science from the University of Illinois in 2009. Congratulations, Randy. This year, ISA also introduced a new award to honor former CCA Soy Envoy Dave Ray of Hillsboro, Illinois, who sadly and suddenly passed away in April. Ray served as a CCA Soy Envoy in 2019 and was passionate about soil management, having spent the majority of his career specializing in this field. The Dave Ray Excellence in Soil Consulting Award recognizes an Illinois CCA nominated for their excellence in soil consulting within the Illinois soybean production system. And I'm proud to announce that this year's recipient is G. Kelly Robertson of Benton, Illinois. Kelly is owner and lead agronomist at Precision Crop Services, LLC, a certified professional agronomist, and has been a CCA since 1994. His territory covers south of I-70 in Illinois and into southern Indiana. Robertson attended Southern Illinois University, Carbondale, where he received his bachelor's degree in 1987 and his master's degree in 2005. He obtained his 4R nutrient management specialty and was named the Illinois CCA of the Year in 2016. Kelly also served as a CCA Soy Envoy, where he wrote articles focused on double crop methods. Congratulations, Kelly. A panel of ISA board members, Illinois CCA board members, and university professionals selected our winners from among CCAs nominated from across the state. ISA would like to thank the nominees for their continued exemplary service to their growers in the soybean industry. Next, I'd like to recognize our sponsors. The Soybean Summit is always a great event, but we could not bring it to you without the generous support of our sponsors. Please join me in giving a special thanks to the companies who helped make this year's event possible by sponsoring keynote speakers and breakout sessions. BASF, Compass Minerals, Asgrow, Farm Mobile, and Brandt. Now let's hear a few words from today's keynote sponsor, BASF.
Hello, my name is Justin Mortz, Agronomic Solutions Advisor for BASF in East Central Illinois. I want to start by saying thank you to the Illinois Soybean Association for allowing BASF the opportunity to be a sponsor of the 2021 Virtual Soybean Summit. BASF has the solutions for today and the innovations for tomorrow. BASF has continually invested in agriculture in addition to local economies and communities. On the left, our newly built soybean breeding station just outside of Seymour, Illinois. This facility houses the soybean breeding team as well as trait integration. On the right, you see our Midwest Research Farm that allows us to conduct practical research locally on our crop protection products and our soybean seed brands like Credence and Zetavo. We've also invested in local production facilities like this one at Hannibal, Missouri, that produces our new Revysol brand of fungicides, Veltima for corn and Revitec for soybeans. Our new portfolio is broad and balanced, with additions like seed and traits. Even with these additions, our mission hasn't changed. We want to help our customers get the most from every acre. When it comes to the soybean acre, BASF has the best products from bag to bin. Now let's take a look towards the future. In the last 10 years, BASF has launched more new innovations than any other basic manufacturer. And over the next 5 years, we are not backing off that pace. We are investing $1 billion per year in research and development. Through 2025, we will be bringing more than 40 new products to market. The entire BASF team here in Illinois wants to say a huge thank you, Illinois soybean growers, for your continued support.
And without further ado, I'd like to introduce this morning's keynote speaker, Dr. Sean Conley, who will be presenting Soybean Biology, a Path to Increased Yields. Dr. Conley is a professor of agronomy and the state soybean and small grain specialist at the University of Wisconsin-Madison. Dr. Conley's research goal is to generate science-based solutions to address real-world problems in soybean and small grain production. This knowledge is then integrated and delivered through his extension program. Dr. Conley has authored or co-authored 117 referee journal articles and has spoken at more than 700 events to nearly 60,000 clients since beginning his academic career. Dr. Conley's commitment to agriculture and the Wisconsin idea has also led him to co-author a children's book entitled Coolbean the Soybean. Please join me in welcoming Dr. Sean Conley.
Thank you, David. Can everybody hear me okay? Perfect. Well, good morning, everyone. And I'd like to thank the Illinois Soybean Association for inviting me down to be able to speak at the opening of the summit this year. I always used to tease Emerson Nafsager, I'm sure many of you know him, that as soon as he would retire, I would take over soybean responsibility for Northern Illinois. So hopefully he's on here or he'll get that message, because I always enjoy Emerson and kidding with him. So I'd like to first of all thank, besides the Illinois Soybean Association, the Wisconsin Soybean Marketing Board, and all soybean farmers, for that matter, across the Midwest. Roughly 84% of my program is funded through checkoff dollars, be that the Wisconsin Soybean Association, the North Central Soybean Research Program, which the Illinois Soybean Association goes and funds to, as well as USB. So again, well, I really try to focus my program on farmers and deliver them the information that they seek and utilize their checkoff dollars. So again, I want to thank them, and I'd also like to thank my co-authors. As you will see as I go through here, this will be a broad reach of things that we're going to be talking about, and I couldn't do it without the team of people that I have around me. Okay, so as I get started here, I just want to remind everybody that the most important thing that I do is make sure I get my information out to farmers. David had mentioned I've published like 117 research papers, but the key point is every time I write a research paper, that information is then written into an extension format and delivered in a palatable pieces and posted on my website. My website is www.coolbean.info. And if you see here, this would be my webpage. And if you want to look at soybean related information, you just go to the soybean research drop down box, and that will drop down and you'll be able to see information from what we've been working on across the years. Another quick thing I'd like to say is I know I speak fast, I really talk fast, and I'm always accused of putting 10 pounds of manure in a 5-pound sack. So this information that I'm going to be talking today is posted on my website, but it is also going to be recorded and delivered to everyone that registered through the Illinois Soybean Association. I know I'm going to get some grief for that one. Anyway, so just want to bring everyone information about that. Just a little bit about my program. So half my program is really focused on variety testing, and we'll see across the state of Wisconsin that we'll have sites across much of Wisconsin, and about 2/3 of my sites are on farm. So about 1/3 of them are on university research stations. The other 2/3 are on farm, and which gives me a good way of looking at different varieties and different programs and different new technologies across the landscape, from anywhere from what I call the tree line up here, which is roughly a 0.5 maturity group bean, all the way down to southern Wisconsin, where we're pushing, you know, late 2s, and we actually have a lot of farmers on this bottom tier of counties that will actually go into northern Illinois to be able to get some soybeans that are actually at early 3.0. So we see a big range in the maturity groups that we grow here in Wisconsin. We also see a good yield range. As you can see in some of our locations, it's not uncommon for us to hit 100 bushels per 100 bushel plots in a given year. So again, just want to bring that and relate that information to the farmers here that are listening. Another cool thing that we get to really think about as I run the variety testing program is I get to test all of these new traits as they come into the marketplace. That way I can deliver information to farmers about maybe if we see a yield drag or a yield lag as these new traits hit the marketplace. So I'll take a minute here and describe this slide to you. Okay, this obviously here on the y-axis is yield in bushels per acre, and on the x-axis we have our different regions. So I'll just mainly speak about the combined region and the southern region, if you will. That'd be the southern, you know, 2/5 of Wisconsin. So if we look here and how you would read this blue bar would be all the varieties that we tested across the state that had the E3 trait. This orangish coloration is the LLGT27. And this gray one would be the Roundup Ready 2 Extend. If we look statewide, we didn't see any yield differences among those varieties that we tested that had the LLGT27 or the Roundup Ready 2 Extend. And we saw a slight decrease in yield on average on those E3s, and that would equate to about 1.5 bushels to 2 bushels. N is the number of varieties we tested, so we tested 88 E3s across the state, 38 LLGT27s, and 117 Roundup Ready 2 Extends. Again, if you look in the southern part of the state, we actually see a different breakdown where the E3s outperform statistically that Roundup Ready 2 Extends. Now, the main point I want to bring with this slide is to let growers know that there are options out there and different trait platforms that you can utilize in order to manage yield. So again, what I'm suggesting that farmers do is focus in on those varieties that perform well for their given environment, and then they have options regardless of what trait they want to use to be able to use. So if you want to use the E3 platform, the Extend platform, the LLGT27, you have options. That's the main point of this is this slide. I want to just bring that to your attention and see what we see, at least in the Wisconsin side. And those farmers here can do something very similar on the Illinois side. Just look at the varieties that were tested at either the first sites or the University of Illinois testing locations. So I'm going to do things a little differently. I was asked to kind of walk through how a soybean kind of grows, and I know this is probably boring, and I'm going to try to not make it boring, as I want to talk about what is physiologically going on at these different soybean growth stages and what you as farmers can do to increase yields. Hopefully it'll be a refreshing way to kind of look at this. So this is, again, posted on my website, this soybean growth and development. And I also sent this as a part of the package for ISA to post when we publish these online. So you'll be able to see soybean growth stage book that we developed. So let's kind of get into this and kind of walk through the soybean growing season, if you will. Now, I put this slide about germination just to kind of highlight a couple things that we really don't really know that well. You know, fundamentally, back when this early work was done to look at, you know, what the optimal or base temperature was on soybean, We weren't really focusing in that much. What I mean by that is we all know that the base temperature for germination and emergence of corn is 50 degrees Fahrenheit. Okay, so just by default, that's what has been thought of and used on the soybean side of things. And frankly, the reason for that is back in the 60s and 70s, when a lot of this fundamental research was being conducted, we were planting beans in June, and we really didn't care because we were having optimal soil temperatures in that 60 to 70 degrees Fahrenheit. You kind of dig into the literature a little bit. The optimal, or the base temperature, I should say, for soybean is actually less than 50 degrees Fahrenheit. And depending on which paper you read, it could be 48 degrees or 46. And again, the main point I want to do and bring that to your attention is the fact that, we were really pushing these earlier soybean planting dates. And the fact is that the base temperature for germination of soybean is less than that of corn. Okay, so I just wanted to bring that to everyone's attention and just make sure that we're kind of on board with that as we kind of dig into this talk a little bit further. Now, what I want to do is introduce a study that we worked on, and I'll be able to bring up some slides throughout this talk. And this is our boots on the ground validation. So from basically 2015 to 2018, we surveyed farmers from across the North Central region. This program and research was funded by the North Central Soybean Research Program. And what we were able to do is we found a little over 8,000 farm fields that we collected survey data from farmers. And again, we see Illinois pretty well represented as well. So with these 8,000 farm fields, we actually have data on over 600,000 acres of soybean production from across the Midwest. We want to really dig into that and figure out how can we use this information in a big data approach to deliver information to farmers to minimize this yield gap. And the yield gap is the difference between what that genetic yield potential is in soybean. Now I would argue for much of the North Central region, it's around that 120, 125 bushels per acre, and what we're on farm getting. And I think if Illinois, I think we had 55 bushels per acre. Let's just use 60 for easy math. So if the genetic potential is 120 and you average 60 across the state, that yield gap is that difference, which is 60 bushels per acre. So one of the things we first look at is this effective planting date. Again, we just earlier talked about that base temperature for soybean germination is less than 50 degrees Fahrenheit. So we're really trying to push farmers in to get those earlier planting dates. And how you want to read this slide, again, is this is a difference in soybean yield based on the days after April 1st, or basically your planting date. And if you look at these different colorations here across the state of Illinois, we have some orange in northern Illinois, some purples here, and some greens across the eastern side. And these are just different TEDs. These TEDs are technology extrapolation domains. Basically what they are, it's a way to group farmers who have similar yield potential, similar water holding capacity, similar growing degree units. And then we can kind of look at these management factors, in this case, planting date, and look at how that influences that response to earlier planting based on TED. So if we see here these northern TEDs like 5R, basically past April 20th, we're losing 0.4 bushels per acre per day. So basically for every 10 days we delay planting, that farmer is losing out on 4 bushels per acre. We get in some of these other TEDs here, this purple coloration is a 6R, and this TED we're losing 0.2 bushels per acre per day. So again, what this allows farmers to do is sort out timeliness of planting. Can you afford to purchase another planter? And when should you be really striving to get those planting dates in based on these specific TEDs across the state of Illinois? Now, so my question, so why are we seeing this response? And the thing we were able to do is dig in and figure out that the reason why, let's say in TED 6R, we're not seeing as big of a response to earlier planting is because the water balance is short. And what I mean by that is in 6R, in a normal growing season, at least over the time we studied this work, those farmers were roughly 3 inches short of water in to maximize yield. Okay, so that's the reason why planting date response wasn't as extreme in that TED 6R as it is up in 5R, because we're getting more precipitation. Okay, so again, this is some physiology looking here. Is the short stick of it is that during that grain fill period, we're 3 inches short of water in a normal year, at least over the time of this growing season. That's why we don't get that response to earlier planting in some of these TEDs. So again, it's a way we can combine physiology with planting date and really understand the nuances of what's driving some of these functions. So as we dig in this, I want to just let everyone know there's basically 2 methods floating out there in order to understand soybean growth and development. So the academics typically cite and use Fair and Cavaness. This is the one that was developed in the 60s, I believe it was, late 60s, I think that paper was published. But in the 1990s, my former colleague, Pella Peterson, decided to screw things up and went and came up with this hybrid method of a way to basically growth stage. So I'm going to show the nuances between these two, but I'm just going to focus on the hybrid method because this is typically the method that most CCAs and farmers are using out there because it's, in a sense, a little bit simpler to understand. So when we dig into this growth staging, obviously we went through the germination process. The first thing we want to talk about is this VE growth stage, or this vegetative growth stage. So one of the key points I want to talk about here is some of the damage to these structures. I know a lot of farmers in Northern Illinois really pushed their early planting date. We had some pretty significant frost damage and several fields were replanted. A couple points to note here is that when this soybean emerges, typically these cotyledons will protect this unifoliate or this growing point. This growing point or this unifoliate structure is very sensitive to cold temperature, and typically if we get a cool weather, you know, at that 28 degrees Fahrenheit for roughly 2 to 4 hours, we can freeze out this part of the tissue. If that does occur, don't worry about it. You're still sitting at 100% yield potential. What will happen is that each one of these cotyledons will have basically axillary meristems will regrow, and you will typically see 2 branches coming out from these axillary meristems. Eventually, one of them will then become dominant, and then we'll have the apical dominance begin again, and we'll have one stem go forward. But again, just to make that point. The other point I want to make is during the germination process, the emergence process, if we lose one cotyledon, don't worry about it. There's 0% yield loss will happen if we lose one cotyledon. If we lose both cotyledons, then depending on where you are, we see anywhere from a 2 to 8% yield loss. And for most of Illinois, I would say we're probably closer to that 2% given the growing period that you have across the state of Illinois. And we typically, if we see that, you may delay maturity about a week. All right. But again, nothing to really stress out about. If you're going out there, you have some crusting, you lose a bunch of cotyledons. You know, for the most part, you're going to be sitting at 2% yield loss. As a farmer, I know it looks ugly. As a crop consultant, you're going to be really thinking about replanting. I would recommend that you just leave it alone. Go fishing, go plant your corn because we were planting our soybeans earlier, and then don't worry about it. Okay, don't stress out about losing a cotyledon or 2 during the crusting process. The BC growth stage is where we see the first true leaves come out. And again, here's a better idea of where these nodes are. And we can see these axillary meristems a little bit better in this picture that we can see. And a couple things to point out right here is these 2 first structures are where the leaves are opposite of each other. What I mean by that is the leaves are exactly opposite of another. From this point forward, we'll see alternate leaves. So I just want to bring this to your attention. And this picture will come up a little bit later when we're talking about flowering and some of the things we're seeing with the earlier soybean planting dates and earlier flowering. Typically, as we're going through, we're trying to figure out yield at the end of the season and trying to estimate yield. We're counting nodes. All I want to do is show this structure that how you can count the number of nodes. You will look for these leaf scars, and this will tell you at the end of the season how many total nodes you had. Again, it's just something maybe more academic, or if you're trying to estimate yield out there based on node numbers, this is just how you would do it if we start losing lower leaves if we have a really high or intense canopy. So again, not as dwell a lot of time here. I just want to let you know how you would count these total nodes based on these leaf scars and their prominence and evidence and where you would find them. All right. Okay, the V1 growth stage. Okay, so what we'll show here is, again, on these pictures, this blue coloration is the hybrid method, all right? The orange coloration is how you would do it the old method, or the fair and Cavan is how the academics typically do it. So I'm just going to focus on the hybrid method, and it will be one open trifoliate. Okay, at this growth stage, V1, we'll have one open trifoliate. This is when we start seeing the infection of nodules. And we might actually be able to see their presence. Typically, they're not quite active at V1, but this is the time frame where those the soybean plant will release what they call these nod factors, and the rhizobia then that are present in the soil will be able to sense those nod factors, move into the soybean root, and then develop, that nodulation process. So again, this is typically when that nodulation process begins. This is also generally the time we're out going and doing stand counts at this point. I'll show you some slides a little bit earlier about how to make stand counts a little bit easier for everyone involved. Now, back to this whole idea of these axillary buds. So what these axillary buds are is, again, if we have some type of hail damage or mechanical damage and we lose some part of that plant, we can see this formation of these axillary buds. And what they'll really do is basically turn out and put some more branching. And why is that important? So over the last 30 years, something cool's really been happening, with this difference between environment and breeding. And in fact, what has happened is today's soybeans, okay, in these lower populations, or if we have damage, we can put on 3 times as much yield on these branches, i.e. where these axillary buds are, than we did 30 years ago. So in fact, one of the reasons why us as agronomists are really supporting and pushing for these lower seeding rates is that with today's modern genetics, we can put on 3 times the amount of yield on those on these basically branches. So which is kind of cool. Another cool thing that breeders have done over the last 30 years is we've basically increased the yield response to earlier planting. And what I mean by that is today's modern genetics have a higher yield potential with earlier planting than genetics we planted 30 years ago. So we're seeing this interaction of cool things happening between breeding, environment, and management that are really helping us push and strive to increase soybean yield. And in fact, not really worry about these lower planting populations, what we used to automatically replant even 15 years ago. So back to this whole idea of basically going out and doing stand counts. So the Wisconsin Soybean Marketing Board funded a project about 5 years ago now called BeanCam. It's free to download, so any farmer that has, or CCA that has a smartphone, doesn't matter if it's an Android or an Apple platform, can go in, just Google BeanCam, and then you can just download it for free, set it up on your phone, and all you do is you go in and you figure out what row spacing you're in. In this case, we're at a 15-inch row spacing, and you figure out what growth stage you're in. So that's why it's important to understand how growth stage. So in this picture, we're at V1 soybean, 15-inch rows. You just take your camera, you line the lines up with the soybean rows, and you snap a picture. Simple and easy. This is what you see on your phone. In fact, this is what your camera sees, behind the background. This is a picture of one of my former PhD students, Marion Lund. She was out there testing this platform and this program, and you simply have it set up, and the default is to basically have 5 random pictures. You walk around, you take 5 random pictures. It tells you what the plant count is, and in this case, our estimated population is 80,000 plants per acre. All right. Then we give you the number, the percent maximum yield. So at 80,000 plants per acre, this field still has the capacity to make 97% of its maximum yield. Okay. Next, we then give you a replant rate that in this case, I would tell a farmer don't replant, but some farmers choose to replant for weed control decisions or just to even up the stand a little bit better. So in this case, we would suggest a farmer put about 60,000 seeds back out there. So if a farmer does that, then you increase to a whopping 98% maximum yield. So in this case, physically going out and putting an extra 60,000 plants per acre, excuse me, seeds per acre out there will only give you roughly 1% added yield. So my default suggestions to farmers are as such. If you're out there planting early and you're on roughly 70 to 80% of soils across Illinois or Wisconsin for that matter, and you have basically 100,000 plants per acre up and growing, you're at 100% yield potential. All right, I wouldn't even worry about that. Between 100,000 and 50,000 plants per acre, I would recommend that you leave that stand alone and not even touch it. We've done a lot of work. At best, you're going to get 2 to 3 bushels. And I frankly, at $10 beans, just to make easy math, $10 beans, a 2 bushel yield advantage would be $20. I would argue that physically, even if you got free replant seed, you as a farmer could not go pay somebody, even yourself, to go out there and replant that field for $20 an acre. I'd rather encourage farmers to go out there and use a residual herbicide in season, excuse me, to help control water hemp or other weed species, because even at 50,000 plants per acre, that soybean field will canopy. It'll canopy roughly a week later based on some of our data, specifically if you're on some better soil. So again, that's just some thoughts and replants and how that soybean plant can compensate. Because remember, we can basically put, even at 50,000 plants per acre, we have 3 times the capacity to put yield on those branches. All right. Now, next slide. So B2 growth stage. So the B2 growth stage, here we see 2 open trifoliates. And what happens is at the B2 growth stage is that's when nodulation, or that's when the nodules become active. All right, so it's a very important time frame to go out there and check that nodulation process, which is that B2 growth stage. So I want to kind of pop this up a little bit more so we can see a little bit more. So just what's going on with nitrogen fixation. So nitrogen fixation will occur all the way from starting around that B2 growth stage all the way through R6. So all the way through R6, which is that seed fill period. So that's the time frame when nodulation and active nitrogen fixation is occurring. A couple key points to remember. The number of nodules is not correlated to how much nitrogen fixed. All right. What I mean by that, you could have similar fixation when you have 10 nodules out there versus 50 nodules, because it's all about nodule efficiency. It's really hard to know that nodule efficiency just by looking at that plant. But again, nodule number, for the most part, is not a good indicator of what's driving that nitrogen production out in that soybean field. Obviously, there's no nodules, that's a problem. But beyond that, that's just want to make that point. The other point we want to make here is if you split these nodules, I'm sure most people know this is common knowledge, if it's pink, that means they're actively working. If they're green, brown, or white, that means no nitrogen fixation is occurring. Some of the typical questions I get is, let's say you have a significant rainfall and you have flooding in a part of the field and we lose some nodules. I usually get a question, well, should I go in and put some nitrogen in those areas? And my typical recommendation is you don't do that, mainly because you have inherent background rhizobia in the soil, unless this is a virgin field and it's never seen soybeans again. So roughly 7 to 10 days after that soil or that the water removes and we can get some aerobic activity again, we'll have nodules start again. So it usually takes roughly 7 to 10 days after that flooding event for new nodules to form and start kicking in and fixing nitrogen again. So again, a little bit of biology of what's going on with nodules and nodulation. Now, there was some misinformation that came out probably about 8 years ago about how much nitrogen a 100 bushel soybean crop takes. And a lot of that was based on some old numbers that were trying to be extrapolated. With today's modern genetics and varieties, a 100 bushel soybean crop requires roughly 375 pounds of nitrogen. All right. So if you're kind of looking at that soybean, that's what it requires. And some of the reasons why this is a big difference, because 500 to 375 125 pounds of N. That's a big difference in terms of what that soil, organic matter, and what those nodules can basically perform out there. So I want to dig into this nitrogen a little bit higher, because it's pretty cool what's going on with today's modern genetics and nitrogen uptake and efficiencies. So how do you read this figure? Because you'll see a couple of these as we go through. So what we see here, this brown coloration, this is seeds, so the amount of nitrogen in seeds. This tan is pods, this is stems, this right here is leaves, and this is fallen leaves and petioles. And what this kind of shows is the percent of total nitrogen, okay, based on what crop growth stage we're at. And this is total nitrogen uptake in pounds per acre. So a couple cool things that are happening again on today's modern genetics. After R5.5, so basically R5 is seed, basically seed fill period. That soybean plant can still uptake 40% of its nitrogen. So that plant is really cooking and really taking up nitrogen, even that late in the seed fill period. All right. Another cool thing that happens is that we are remobilizing nitrogen. So 67% of the vegetative nitrogen that we've taken up during the growth and development of that crop is remobilized, basically stripped out of these plant parts and shoved into that seed. Because again, soybean seed is high protein demand, and nitrogen is one of the components that goes to feed that nitrogen, excuse me, that protein component of soybean. So let's dig into it a little bit more. What's been happening, okay? So these are today's current genetics. In this brown color and this tan color is the genetics that were released in the 1960s. So two things that are really happening is, number one, we see this uptake after R.55. It's 3 times the amount that we saw in the 1960s genetics. And the vegetative nitrogen remobilization is roughly 15% higher. So again, we're taking up more late in the season, okay? And then we are remobilizing more, basically stripping it from the leaves and shoving it into that soybean seed for protein purposes. Now, in terms of the N uptake rate, I'm going to show you this figure. And again, all this information is on Coolbeans. I know I talk fast, but all of this information is on there. So you can dig into this more if I'm going too fast for you. All right, so how do you read this figure? This is N uptake rate in pounds per acre per day on the y-axis. On the x-axis, again, this is growth stage. And on the z-axis, this is percent of peak rate. So in low yield fields, which would be 54 bushels and lower, this would be the uptake peak rate and duration. In average fields, where we're averaging 66 bushels per acre, this is the peak uptake rate and duration. And in high yield fields, we're talking 82 bushels and higher, up to, and in this experiment, we got up to 110 bushels per acre in some plots. We see an even higher uptake rate and a longer duration. And the other cool thing is, again, soybeans are amazing. What's going on with modern genetics is so cool that at R8, okay, that's basically the day that soybean dies, all right? Let's say we're right at R8, it's about ready to keel over, and it doesn't keel over, but basically stop all growth and development. That plant is still taking up 63% of its peak nitrogen. So again, that soybean plant in these high yield situations are still taking up and moving nitrogen from just not just the plant parts, but from the soil at 63% of its peak rate. That's pretty amazing. And again, the point I'm making here is that soybean plant is so efficient that I think in a lot of these cases, we really don't need to be adding additional nitrogen to the system, even in these high yield environments. And here's another image to really further hammer that home. So again, this is the N harvest index. And you may be saying, what in the world is that? So what the N harvest index is, this is the total nitrogen that plant took up during the growing season divided by the N removal of the seed. So in a low yield situation where 60 bushels per acre, That soybean plant is only looking at an end harvest index of roughly 70%. We get up to these higher yields in today's modern genetics, we're looking at an end harvest index of 90%. What I mean by that is 90% of the nitrogen that went into that plant biomass is stripped out, shoved into the seed, delivered to the elevator as protein source. All right. So in Wisconsin, we don't even talk about fixing nitrogen or having an N credit anymore, because in fact, in these high yield situations, we're effectively doing an excellent job of stripping and removing almost all that nitrogen out of that plant. We'll still give it a rotation benefit, which is similar to what that old N credit was, but we don't even talk about N credits anymore. Because frankly, this plant is so efficient at stripping it, especially in these high yield situations. There's probably not a lot of nitrogen left over for those soybeans, or excuse me, for the next year's corn crop. Now, I do get a lot of questions of adding additional N into soybean. And again, this is kind of a crazy figure here, but about 3 years ago, I asked my colleagues from across the country, hey, just send me any data you might have on N response on soybean. All right. So we basically got yield information from 207 environments. So basically 207 experiments from across the country. And how you would read this figure here, this is yield in bushels per acre. This is the N rate, like how much additional nitrogen we put out. And we had plots that were 30 bushels per acre yield range, and we had plots that were over 100 bushels per acre. And how you would read each one of these lines, this is each of these 207 yield environments. This is the yield response to adding additional nitrogen. All right, so let's look at this one here at 90. You see that's pretty flat, even by putting out as much as 405 pounds of additional nitrogen. So the point I want to make here is I don't think in most cases it's either cost effective nor yield effective to put any additional nitrogen on soybean. Given what we talked about, how efficient that plant is, these high yield environments of stripping that plant dry and shoving all that nitrogen in the soybean seed. Okay, so I'll leave it with that. Again, feel free to go to Coolbean, check out some more information. V3 growth stage here is basically obviously three open trifoliates. I'm not going to spend a lot of time on this one. Basically, we already know this. By the time that soybean plant is at V2, that field should be weed free. This is just some older data. I think we're all pretty much know now with water hemp, and the recommendations from weed scientists: start clean, stay clean. I would echo that. The point I used to make with this slide is to make sure that if farmers were using glyphosate only, which I don't recommend, but back in 2008 and 2009, that's what a lot of farmers were doing because it was effective and it was cheap. We were still losing anywhere from just spraying at one time and cleaning up weeds at V3 to V4, 3 to 9% yield loss. And that was hidden yield loss because back in those days, glyphosate was very effective at controlling weeds, and a farmer might just go out with a one pass V4 and then really clean up the weeds and then didn't think he had a yield loss. Well, in fact, the farmer probably had up to a 10% yield loss due to this hidden weed competition that we couldn't pick up because, again, glyphosate at those point was very effective. All right. V4, I'm looking at my time. I'm going to quickly go through some of these pretty fast so I can make sure I get done on time, but here's this V4 growth stage. V5, the point I want to make with the V5 growth stage is this is right at this point where we start seeing rapid dry matter accumulation. So this is when that soybean plant jumps, is right at that V5 growth stage. Again, I'm not going to dig too more into how you do vegetative growth stage, but I just want to remind everyone that we redrew the maturity group map. It's really hard to see here, but really trying to get a sense of what's going on with how the maturity groups have changed across the state of Illinois, just because of our earlier planting dates and the longer growing season we're experiencing. So I'm not going to dig too much into that today. I do want to remind people about these different growth habits. mainly because the two we are dealing with right now are indeterminate, which is basically mostly grown across Illinois and north. We don't get into determinate beans until we're, late 4s, early 5s is where we see that transition. The difference between these two, just as a friendly reminder, is in indeterminate, we continue to put on new vegetative growth after flowering begins, whereas determinate beans, once they start putting out flowers, then vegetative growth, basically ceases at that point. So the R1 growth stage. So this is where we have first flower, and this is the point, if you have a history of white mold, we really need to start thinking about making that first fungicide application. Dr. Damon Smith, he is our plant pathologist here at UW-Madison. He's actually seeing that based on the growth habit of soybeans and how we're planting in earlier, this R1 for white mold, we might actually be more efficacious of pushing it to R2, which would be full flower. So one thing I will want to quickly talk about, and I'm not going to spend a lot of time on this. This publication is on my website. It's called the Soybean Flowering Fallacy. And the old rule of thumb is that soybeans will not flower until June 21st. However, I think we've seen lots of pictures on Twitter with soybeans going in late March, early April across Illinois, and we're starting to see flowers basically forming in that first week of June. And what's going on? In short, I'm going to quickly bruise through some of these lines. In short, what's going on is at this unifoliate level, if we're planting early enough and the dark level light is at that point, we could trigger flowering this early. So basically what happens is we're triggering flowering earlier at unifoliates when we're planting earlier because it's based on the proportion of light. So again, I have lots of slides. I can talk about this, but to keep things moving, I just want to introduce this policy. It's not a policy, but this idea and why we're seeing these earlier flowering dates. Okay, so back to white mold. Again, this probably only matters to the northern third of Illinois, but I want to remind everyone out there that Damon Smith developed this app. It's called Sporecaster. It's free to use. It was developed and sponsored by the Wisconsin Soybean Marketing Board. And you can just go in, and what it does is it helps you predict risk level in a given field for white mold. Okay, so it's a simple app to really help you know when you should be spraying a fungicide targeted for white mold management. On the other side, he's called an app called Sporebuster. And what this allows you to do as a farmer is go out, get quotes for all the different fungicides that you can apply toward manage to manage white mold. Put your own prices in here because every farmer gets a different buying power, different product, different program. And then you can run the app, and it tells you which fungicide to apply, which one will give you the highest return on investment. So go into either the Google platform, or excuse me, the Android platform, or the Apple platform, Sporebuster, Sporecaster. Download them; they're free to use. Good tools to use to help predict when to apply a fungicide for white mold and which product to use. R2, I earlier talked about that. Probably a better timing now for white mold, just given our earlier plantings and when those apothecia are releasing those spores. R2, quickly talk about this. This is when we see the high potassium uptake rate, is right around R2. So this is when that plant is taking up a lot of potassium. And again, if you look at this structure, it's a little bit different than on the nitrogen side of things, because remember on the soybean, excuse me, on the nitrogen side, we're taking up over 40% of our nitrogen was taken up after R.5. In potassium, it's different. We're only at 10%. So by the time that soybean plant really starts to put seeds out there, we are almost done taking up any potassium from that soil profile. Now, I think many of you probably know this, but potassium is what I call soybean is what I call a potassium pig. It'll take up and scavenge as much as possible, shove it in the structures, into our into our stems, into our petioles, into our leaves, and then it'll use what it needs in terms of to maximize yield. And then whatever's left obviously goes back as that dry matter that's after the combine has gone through the field. So I'm not going to spend a lot of time on potassium, but just know that if you're out there and you're pushing 100 bushel beans, you also need roughly, and you will be removing 117 pounds of fertilizer equivalent K2O. So 100 bushel bean crop, you will be delivering 117 pounds of K2O to the elevator. So just make sure when you're going out there and putting these nutrients back out in these situations, especially high yield, you're removing a lot of K from that soil. You need to make sure we have time to go out and put that back out there before the next soybean crop. Our three, this is when we were first potting. Again, I'm just, and this is also the last time we would actually ask for a to put a white mold treatment out. On the flip side, R3 is when the prophylactic fungicides go out for all other types of pathogens that you might be focusing in on. In terms of what we've done, again, remember back to that survey where we had 8,000 farm fields and over 600,000 acres of data. What we basically show here in this figure is the difference between those farmers that put out a prophylactic application of a fungicide, foliar fungicide and insecticide, versus those farmers that didn't in a specific TED. So again, if we're looking across Illinois, see it's hard to see here in this picture, it's pretty small, but in TED 6R, basically it was right in this one-to-one relationship that showed that in that TED, at least given the 4 years, in the absence of any type of pathogen, specifically frog eye leaf spot, just prophylactic, no scouting, no pests, we really didn't see a big difference to yield. However, up in this TED 5R, we're looking at a 6 bushel yield increase by a prophylactic application of a fungicide. So again, understanding when and where these work will help really drive the ROI for farmers moving forward. Defoliation, I'm going to skip that one. I'm going to skip R4, just to keep on time. This is just a seed fill period. They're really kind of focusing in on some good pictures that you can kind of look at here. I'm going to skip R5, skip R6, skip R7. Again, these are just more informational. You can kind of go back and look at these at a different time. R8 is reproductive growth stage. Again, this is the point. Look at this soybean plant here. In high yield situations, even when the plant looks like this, R8, the day it dies, remember 63% of its peak and uptake is still taking up at that time of the growth season. So again, just want to point that out, and I just think that's such a cool factoid that we were able to pull out recently through some of our work. I know there's a lot of these crop uptake and removal calculators out there. Go to Badger Bean, that's the Wisconsin Soybean Association webpage, and you can look at our crop removal uptake. So in this case, I use 80 bushel beans. So an 80 bushel soybean crop will remove 274 pounds of nitrogen, roughly 60 pounds fertilizer equivalent P2O5, and almost 100 pounds of fertilizer equivalent K2O. So again, just helps you as a farmer, as a crop consultant, understand how much fertilizer is basically being removed from that field as seed and delivered to the elevator. All right. In Wisconsin, and I know probably parts of Illinois too, we do see removal of stover. And I always want to make this point is we see a lot of soybean stover baled up and used as bedding for livestock. And I do know that I think the farmer David on here has beef cattle, and that they may do this too. The point here is for every ton of dry matter that is removed from that field, you're removing roughly 40 pounds of fertilizer equivalent K2O. The reason I put this on here as well is for those farmers that are either baling it off themselves or selling this stover as straw or bedding, make sure you're getting a high enough price to cover the amount of nutrients and fertilizers that are being removed from that field. Okay, so in my last 5 minutes, I want to make everyone aware of this project we're going on. So earlier I talked about these 8,000 farm fields and 600,000 acres of data that we had. What we were able to do with that is basically use some modeling approaches to then try and predict what are the best management factors in a given TED a farmer can do to minimize that yield gap I spoke about earlier. So I had to have these slides in a couple weeks ago, so I'm only going to be talking about 2019 data, but my 2020 data is on my website, coolbean.info, and you can look at that to see the updated version and the differences between 19 and 20 data. So again, this is all on-farm, large plot, replicated data across the state, and I do have a few cooperators here in Northern Illinois that worked with me. And if anyone wants to work with me in 2021, it's the last year of this project, is reach out to me and I'll get you the protocol and you can kind of help out. All right. So there's just a picture of what we have, and what we have are these two different treatments. So it's kind of a systems project. So the reference is what farmers typically do for a given area, in a given TED. That's our reference. The improved is what our modeling told us that a farmer should do to improve yield. And these are the different treatments based on the different TEDs in these different states. So we're looking at changing, planting earlier, changing maturity group, using a foliar fungicide or insecticide, and decreasing seeding rates. That covers a lot of the different treatments across the different states. So, quickly, I'm going to show you how to interpret this. So, on the x-axis right here, this is yield and our reference. So the reference is what farmers are typically doing in that TED. The yield in the improved, that's what our basically our stats have told us farmers should be doing to minimize that yield gap. This red 1-to-1 line, again, is if a specific field fell on that 1-to-1 line, then you would get a similar yield between the improved treatment and the reference treatment, or what typical farmers are typically doing in that area. Across all 47 on-farm plots across the Midwest, we saw on average a 6 bushel yield increase by implementing our improved treatments over our reference treatments. And on average, we saw an average net profit of $55 per acre when farmers used our improved treatment over our over the reference treatment, which is what farmers are typically doing in that area. So it's very good. So we're seeing both the cost savings in some cases of decreasing soybean seeding rate, but also the advantage of using a foliar fungicide and or insecticide at R3, given which TED we might be looking at. So with that, I'm going to show everyone my webpage. Again, my webpage is www.coolbean.info. I am at BadgerBean. That is my Twitter handle. Feel free to follow me on Twitter. And in the growing season, when we're out looking at plots and seeing what actually is going on and our own boots on the ground, I have a blog I write during the growing season called thesoyreport.blogspot.com. So with that, I don't think we have time for questions. Feel free to just email me questions. And I think I'm going to stop so everyone has a short opportunity for a bio break. So thank you, everybody. Thank you for letting me speak today. And where's Rachel? I'll turn it over to Rachel.